We're going to be talking about dysrhythmias and conduction. Okay, so with dysrhythmias, it's actually talking about the electrical conduction. How is it that the heart itself contracts? So as we know already that the pacemaker of the heart is actually the SA node. And so here in this diagram of the heart, we're actually seeing how the electric current sent through our heart from the SA node over to the left side of the atrium, and then is conducted through the bundle of His and then comes up on the Purkinje fiber on this area. Now, with each contraction of the heart, it is mimicked. That's what we're looking at on the EKG. So on the EKG over this side here, the P actually represents the contraction of the atriums, both atriums. So when we look at the EKG reading, the P or represent the contraction of the atrium, both right and left atrium. Now, after the contraction of the atrium, there should also be a relaxation. The relaxation of the atrium is lost in the QR complex, meaning that you cannot see that it is relaxed, but it is. The QRS complex is a contraction of the ventricles. And so that's why you see this high voltage come so high up and then down, and this represents the contraction of the ventricles. Then we see the T. The T then represents the relaxation of the ventricle. And when the ventricle is relaxed, that's the time then it is more likely to be filled by blood coming from the atrium. So the P wave, or the first rise of the isometric line on the EKG paper, is actually the P wave, which is a contraction of the atrium. The relaxation of the atrium is not seen because it is lost in the Q complex here. Then the QRX complex is a contraction of the ventricle, and then the T is actually the relaxation. Why is it important for you to know that? Because when they're going to show you a strip, you have to look at these areas to find out what part. Is it an atrial fibrillation? Is it a ventricular? So in order for you to know if it's an atrium or if it's a ventricular problem, then you have to know on the EKG what represents what. The atrium diastole. Diastole mean what? Because we have, when you're talking about blood pressure, what do we have over what? When we're writing blood pressure, how do we write it down? Systolic over diastolic. And which number is the highest number? Systolic. And systolic represent what? Does it represent relaxation or contraction? So if we should look at this chart right here, we see this is the beginning of from the beginning of the contraction, which means that this line is on the isometric line. It's not off yet. So when we have a contraction, it is actually, the systole is actually the contraction. That's why that number is the higher. So as the number gets down low, then it begins to relax. Okay? So the systole is actually the contraction. Diastole is actually the relaxation. So in terms of the normal sinus rhythm, the word sinus tells us that the beat is coming from the SA node. Any beat that comes from the heart and that is initiated by the SA node is called a sinus rhythm. So there are a couple of things that they look on when they are looking to identify if it is a normal rhythm or not. Not only that they're looking at the contraction and the relaxation, but they're looking at the length. Like for example, normal heart rate is 60 to 100. And the SA node, because it is a pacemaker, it actually, that's the beat of the SA node. That's the rate of the SA node, and that's from 60 to 100. Now, we tell if it is regular by looking at the R. If the R is the spike of the second isometric line. So if we should look at each R, we're looking at the space between them. Are they the same? So we're looking between these two R's, then these two R's, then the other R's, and we're looking at the pattern are the same. If I should use something called a compass, I know it's called something different in America, and if we should measure these are the same. Between each R, they are the same. So the rhythm is considered regular. So let me repeat that again. If you want to find out if a rhythm is regular, you can look at the R's and look at the spaces between the R's. And if the spaces between the R are basically the same, that means the rhythm is regular. So another thing that they look at when they're looking at an EKG, they look at the PR interval. The PR interval is measured from the beginning of the P to the beginning of the R. So in that, it tells you the width, which is supposed to be 0.12 to 0.20. And they're talking about the small boxes. The small boxes that are on the EKG strip, 5 small boxes make up one big box. And so the big box is 0.20. So each small box inside is point what? No, if the big box makes is 0.20 voltage, each small, and it has how many boxes? So if you look at this, then we have small boxes. And if you look, it says from the P, the beginning of the P, until the end of the P should be 0.12 to 0.20. All right. And the Q to the S, or through the ST segment, it should be less than 0.12. So one of the things is that if the reason why this is important, because the larger it is, it tells you what kind of issue may be going on with the heart or with the patient. So it's very important to have an idea that if the P is wider than 0.12 to 20, then there is a problem. And so this is important. So here's what I want to show you. One box, one small box. So if you look, there's a big box, and let me take my thing and show it to you. This is a big box, and this big box is 20 seconds. And that's what they were saying here, that hey, if the P fall in a big box, 20.20 seconds, then yay, 0.20 seconds, then fine. Okay. But if you look that in one big box, how many small boxes do you see? 1, 2, 3, 4, 5. 5. That means each one is 0.04 seconds. So one small box is 0.04 seconds. Okay. And if you put them all together, then it makes 0.20 seconds. It is important because it measures voltage and also rate. So look, this big box here altogether is 0.20 seconds, but one box is 0.04, 0.040, and it makes sense because when you add it up, you get 20. Okay. First and most important thing, you want to assess your patient. And I think I tell you this. If you're out of the room and you see the machine is telling you that the patient is having a VFib, look at the patient first, because it could be something wrong with the monitor. It could be that the leads are not on. It could be that, so you want to look at your patient. So even though the machine is saying something, make sure that you assess your patient. So there is a 5-step approach in order to analyze EKG rhythm or strip. You're going to look at the rate first. You're going to look at the rhythm. You're going to look at the P wave, then the PR interval, then the QRS. So look at an EKG strip systematically. First, what is the rate? Second, what is the rhythm? Third, P wave. Is there a P wave? Second, PR interval. And then fifth, QRS complex. There is something, no, that's not it. So how do we calculate the rate? You count the number of electrical pulses as represented by the QRS complex.
So they say count the number of P wave, that's an atrium wave, and then also ventricular, you can count the amount of QRX complex. But remember that the complex is when the complex that you're counting is caused by the contraction. One is caused by the contraction of the atrium, which is the atrium rate, and then another is counted by the ventricular, which is the ventricular rate. Okay, so if you get a strip like this, from here to here, you know it's 3 seconds, and then as it extends, you know it's another 3 seconds, so you know that is a 6-second strip. So each mark that you see on top is 3 seconds. So that's so you know if it's a 6-second strip, a 3-second strip, and so forth and so on, okay? Okay. So the strip is marked by 3 or 6. So sometimes you may not. If you don't see multiple mark on the top and you only see one, that means it's a 6-second strip. So what you do, you count the QRS complex within the 6 seconds and then multiply it by 10. For example, let's look at this. This is a 6-second strip. It doesn't work with 3 seconds. This is a 6-second strip. So what I'm going to do is I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9, and I'm going to multiply it by 10. And so 9 times 10 give me 90. So that tells me that the heart rate is 90. A 6-second strip, you count the QRS complex. I go to the top of the R and I count the R's, how many of them? And then I multiply it by 10. And that gives me an estimate of what the heart rate is. Okay, so here is this strip. Here's another strip, 6-second strip. So as you can see, you see one dot is here, or another dot is here. That is 3 seconds, and another dot is here. That tells you that is 6-second strip. Now, so this is a 6-second method. Now, this chart is so complicated, a lot of people don't use it. So it's a count spaces between the R's to R. Find the number of spaces on the chart to determine the rate. So, however, in this one, they find the R, they count the small boxes between the R, which is 15. So on the chart, find 15 spaces, and then we tell you. So we go on here, and I find 15, it tells me that the heart rate is 100. Then step 2, you know, a clock ticks like this. Tick, 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 tick. It's looking at that's the rhythm of the clock, and the rhythm of the clock is consistent, meaning that you don't hear tick, 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 tick. No, you don't hear the clock. The clock is consistent in the rhythm. Whether it is fast or it is slow, the rhythm should be consistent. And it's just like dancing. You ever see some people who do not have any rhythm? That's when something is wrong with the heart. But the rhythm is that it is consistent, whether it's fast or slow. So after looking at the heart rate, you're going to look at the rhythm. So it's a sequential beat of the heart as a result of the generation of the electrical impulse. So it's classified as a regular pattern. That means the interval space between the R's are the same. You're going to look at the spaces between the R and say, are they the same? Look at this. So you're looking, these are the R's, and you're looking, is the space same as here? Is it same as here? Is it same as here? Or the space is the same? And if yes, that means it's regular. If it is not, if some is small, some is large, then it's considered irregular pattern. Okay, so measuring a regular rhythm. So you measure the R intervals between the R waves. If the interval vary by less than 0.0 second or 1.5 boxes, the rhythm is considered to be regular. You may not have them exactly the same, but they should not vary far off. So measure an irregular rhythm. If the interval between the R's are greater than 0.05 seconds or 1.5 small boxes, the rhythm is considered irregular. So for the P wave, you want to ask 5 questions. Are there P waves present, which there should be? Are the P waves occurring regularly, meaning that is there a P wave for every QRS complex? Are the P waves smooth? Are they round? Are they upright in appearance? Or are they inverted, meaning turning down? Do they all look similar? Those are some of the questions you should ask, because if they don't, that tells that something is wrong with the atrium. So the PR interval. So let's look here. This is the P wave, which is a contraction, but the PR interval begins from the contraction of the ventricle, and then when the QRX complex is going to begin. So that's the PR interval. All right, so that's the time, because if it's too close, that means you're having a contraction too fast. It tells a whole lot, which we're going to go into later on. So this is the PR interval, the beginning of the contraction of the atrium to the beginning of the contraction of the ventricle. So a couple of things you want to ask about the PR interval. Are the PR intervals greater than 20 seconds? Is it less than 0.12? Is it less than 0.12 seconds? Are the PR interval consistent across the EKG strip? Do they look the same from complex to complex? So the QRS complex, which is here, QRS, this is the first negative or downward reflection of this large complex. Because remember, here's the isometric line, flat, flat, flat. This is the first spike, but this is the first inverted, which is downward. The R wave is the first upright or positive deflection following the P wave, which is the tallest. What it's saying is that after the P wave, this is one of the first upward one. Then you have the S, which is the sharp negative downward reflection that is followed by the R wave. Okay, so normal interval is 0.06 to 0.12 seconds. So a couple of questions you need to ask. Are the QRX complex greater than 0.12 seconds? And that's in width. You're looking at the width of it. Are the QRX complex less than 0.06 second? Are the QRX complex similar in appearance across the EKG strip?